All right, I want you to look at your notes. We're on our last lesson of our proportion unit already. It's a short unit and my favorite. It kind of bums me out that it's the shortest. But notice that your name is different from my name. I would like you to turn your name to 6D. 6D. We are doing scale factors today. Yesterday we did 6C2. Today we do 6D, scale factors. So your learning target, you can identify scale factors. That means I'm going to give you a situation. You're going to tell me what the scale is. And then you can create a proportion to solve for missing dimensions. So everything is related to proportions. And proportions are going to be hanging out around us for the next few units. They keep popping back up, okay? All right, so scale drawings are used with maps or models. Anybody that is an interior designer, when they're planning, I'm spelling that wrong, when they're planning like how to decorate a room, they would use scaling too. Engineers also use scale factors as well when they're trying to develop a prototype or some kind of product. They don't want to make a ginormous one at first. They want to make a little one, but they want that little one to represent exactly what that big one's going to be. So they have to have everything to scale. Okay? Scale factor, we usually say the fake is to the real dimension. Now when I say the fake dimension, I mean the drawing, because dimensions are always real. An inch is real, and a mile is real. I'm talking about the product. Like a map is not a real actual distance. Like you can't walk an inch or 12 inches and get to California. You know, it's representing just a situational factor. So it should be fake is to real as fake is to real. We tend to always put that fake measurement or that model measurement on the top. Okay, now it doesn't really matter because remember proportions, what matters is the pattern. But it does matter when we're talking about what is the scale factor. What people always say is like 1 inch represents 300 miles or 2 centimeters represents 18 feet or something like that. So it's always that model dimension goes on the top. So a map has a scale factor of 1 inch is to 50 miles. Notice that I boxed that off so I knew what my scale factor was. The distance between the two cities on the map is 2.5 inches. How many miles apart are they? So the two things, the ratio I'm comparing is inch is to mile. Also known as the fake measurement, the map, is to the real measurement, the actual distance. You use your scale factor for that first ratio. My scale factor is 1 is to 50. And then 2.5 inches. Inches is from my map. My map is going on the top. Again, solving is a proportion that we've done since the second lesson of this unit. 1x equals, what's this?
125.
Thank you, 125. So just x is 125. Understand it in context, 125 miles. So they are 125 miles apart. Okay, next one. Your car is 18 feet long. If you are building a model that is 2/3 of the dimension, how long will your model be? Now, there's a couple of ways you can do this, because you should see that vocab word of. 2/3 is like of, 2/3 the dimension. You can multiply. However, let's connect it to scale factor. So this would be my scale factor. Remember, scale factor is that fake measurement is to the real measurement. The model is to the actual. So it's 2/3. 2 is to 3. As if your car is 18 feet long, that's a real thing. Cars would be about 18 feet long. Now a model wouldn't be. And find my x. 3x equals 36. X equals 12. And I don't know what my units is, but my model would be 12 units. because it keeps that same dimension. Good call. Feet. Okay. A map has a scale of 3 centimeters is to 18 kilometers. If Riverside and Smithville are 54 kilometers apart, then how far apart are they on the map? Again, I write down what I'm comparing. Centimeters to kilometers. Then I say, what is that representing? It scales, so I have a fake measurement is to a real measurement. All right, so that just took up some of my time. No problem. Here's my scale factor that always goes to the first ratio. 3 is to 18. They are 54 kilometers apart. Good thing I write down what I'm comparing on my ratio, because I just put that 54 right down at the bottom with my other kilometer. Solve that proportion. 54 times 3 divided by 18 equals 9. X equals 9. Think about the context. I'm talking about centimeters. So they are 9 centimeters apart on that map. All right, that's applying scale factors. That means I give you a scale factor, I give you another situation, you figure out either what the model is or what the actual distance is. Learning objective number 2 today is to actually determine the scale factor. Okay, so here's this lovely little vocabulary word, maybe box, cloud it or something, box it up, highlight it, make little stars by it, I don't know. Just so your eyes can see, scale factor is one ratio. It's not a proportion, and it's not just a number. It is a ratio. You're comparing two quantities. Inch is to mile. Feet is to kilometers. Centimeters is to feet. Okay? You're comparing two things. So you need to have a ratio, a top and a bottom. Okay? It's just like unit rate, but backwards. Typically, you always have a 1 on top. If you read most scale factors, they always say 1 inch represents like 200 miles or something like that. Okay, so a 1 should be on top. On a particular map, every inch represents 90 miles. What is the scale factor? So I should have inch is to mile, also known as your fake or your model is to the real one. So 1 is to 90. So in Schoology, I go 1/90. Okay? You have to have two numbers. A scale factor is a ratio. A ratio compares two things. Okay, the length of a wall in a floor plan is 6.5 inches. The actual wall is 78 feet. Find the scale of the floor plan. So I should have inch is to feet, right? Yeah. Or plan is to real. I don't know, however your brain thinks about it. So I have 6.5 is to 78. Now that is the scale factor, but it's not the proper scale factor. Just like 5/10 is 1/2, but it's not in proper form. You want a 1 on top. So just like unit rate, let me connect it to that first lesson in Unit 6. Unit rate, if I spent $48 on 12 shirts, I want to know how much per shirt. I want to know how much per inch. It's backwards. So I would do dollar is to shirt, and I said, 48 is to 12, $4 is to 1 shirt. That's how I did it. Scale factor is unit rate backwards. So I want to know how much feet in 1 inch. How much does 1 inch represent? 1 inch is how many feet? Okay, well let me just figure that out. 78 divided by 6.5. And this is where kids go wrong. Kids type in Schoology 12. Is 12 the scale factor? No. My scale factor is 1 over 12. So be very, 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 very careful. That's where scale factor messes kids up. A scale factor is a ratio. You should have a top and a bottom. Okay, last one. The length of a drawing of an object is 6 inches. The length of the actual object is 84. What is the scale? So it looks like, well, they're both inches, so what the golly, which one goes on top? So that's why I know fake is to real. It's always that fake measurement is the real. The drawing one goes on top, the actual is 84. This is not the scale factor. It is, but it's not. I need a 1 on top. So I gotta figure out that bottom. I just have to press clear about 1,000 times in this calculator. Okay, 84 divided by 6 equals 14. Is 14 my scale factor?
No.
No. What's my scale factor? 1 over 14. You should always have a fraction. Learning target done.